Hi, Russell Hobbs Breadman, Healthy Options Bread Maker. Now some of you may know that I volunteer at our local repair cafe, and somebody asked could we have a look at this, and it's got a bit of an unusual fault. So I'll just get a power lead, I shall plug it in and I'll show you what it's doing. I'll just open the top there so you can get a look inside. So we'll plug it in. And as soon as you switch it on, it starts going by itself. Hit stop, nothing happens. Pause, select. Hit stop, it won't stop. So I'll just switch it off here. So it's kind of got a mind of its own. They possessed the bread maker. So they don't actually use it for making bread. What they use it for is for making pizza dough, and that's pretty much what we use our bread maker for as well. Because we live in a very rural place, there's not many takeaways around where we are. I mean, I think the nearest McDonald's is round about 20 mile away, so if you want to get one and then bring it back, it's a 40-mile round trip and about an hour's drive. So, and it's the same for things like pizzas and that stuff. So we use ours to make our own pizzas. So if I get this working, that's what we may do at the end of the video, just to do a real world test on it. So anyway, you've seen the fault, so let's see if we can figure out what's wrong with it and hopefully repair it. So I think the first thing I might do is see if I can remove this lid. There we go. We'll get that out of the way. And how does this come apart? Let's see if I can get this basket out. There we go. I don't know if that's better or worse because the glare seems to be affecting the camera, especially with it being so reflective. I can see a screw down here. A screw there. And there's a screw at the back there. So I might see if this well, I assume this is where the electronics are going to be, in here. We'll see if we can get that off and then see what that reveals. Oh, that came off quite easily. I can see a motor on that down there. Right. So that's the motor that controls the dough mixing part down there. I can see a heater down there. This is unplugged from the mains, by the way. I can see the heater element, which is just down here. Happy to see it there. Looks like some kind of thermostat or safety device there in case it overheats. Looks like we've got a temperature sensor here, just on the side of it. And a little transformer down there, which says output 20 volts AC. So I wonder if that's what runs the electronics then. And there's something else down there. Oh. I'm not sure if it's just a filter or something just down here. And that looks about it. Not actually a lot in there. So I think the problem is going to be in here. So let's see how this comes apart. Get these cables out. Right, so what do we have in here then? A few diodes there, looks like a bridge rectifier. A little solenoid here. And I've not seen that move, so whether or not that's working or not, I don't know. Looks like that goes to these 2 points here. And what else have we got? And BT08, well that's a triac, so we've got a couple of triacs there. And a couple of relays. And I guess this cable must go to the front display here. And it's actually got written on here. I don't know if you can see that, I might zoom down a bit. See if we can zoom down a bit on this. There we go. So on this board here, we've got int 0, which is our interrupt pin, I guess. Buzzer driver. Temp CTR, temperature control, heat, extras, whatever that is. Ah, I know what that is. There's a little compartment on the lid, and I bet this solenoid flicks out and opens the lid on the other compartment. That's what that must be for. Then we've got motor R and motor L. So would that be left and right? So at least we know what the pinout, hopefully, on this connector is. However, it looks like there's more pins than what there is what's actually written on the circuit board. So we've got 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, and 11 pins. So I don't know what the extra pins are for, unless they're power supply and ground, maybe. It could be. So why has it got a mind of its own? That's the thing. I wonder if I can get something just to rest across the top of this, just to hold this board, because it sort of wants to drop inside. So I might see if I can just get a bit of cardboard or something just to support this board a second. And resume. So that's a little bit better now, at least it's not going to fall inside. Right, let's have a look here then. So this red wire here, I don't know if you can see just down there, just zoom in a bit. It's actually marked there here, so we can rule that one out. And this one here is marked Moto R, and this one here is Moto L. And I'll just try and find something to point with here. And it looks like there's either been a space for a relay, if they had a relay fitted, but because this one's using a triac, that one's motor R and that one's motor L. So I wonder if one of these triacs are shorted out. Let's get the test meter and we'll just have a check just to see if we've got any shorts there. No, I'm not sure of the pinout of these triacs, so just better go and double check that. One moment please. So I've just been to check the pinout of the triac, and pin number 3, which is over this side, is the gate pin. But I'm not sure which triac is the one that could be faulty, so what I might do is just unplug one of these spade connectors here, either motor R or motor L, and we'll see if the motor comes on. So just try and figure out which one it is. These are the type where you've got to press the little button in before they'll actually release. So I've unplugged that one. I'm just going to plug it in again, and we'll see if it starts springing into life. So here goes. Right, well it didn't spring into life that time. So I guess it's this one here. So that's motor R. So let's see. We should get about 0.70. I'm not sure if that's quite right or not. Let's just try with this one. See if we get a similar reading. I don't think I can even get the probes in on this one. Right. Let's just double check to see if we've got a short between the two pins here, and we haven't. But here we're measuring about 0.6 voltage drop. But we're not on that one. So I wonder if there's another component or something that's causing this to switch on. because we do have 4 transistors, well, we've got more than 4 transistors here. Let's see if any of those go to the gate pin. I'm going to probably go through a resistor or something, I guess. Might have to pull this board out to have a look. I'll see if I can pull this board out and we'll get a better look at it. I'll tell you what, I'm just going to take a photograph so I know where all the wires go. Or will this board just flip over? Let's see. I see a screw there and there's 2 screws down here. Wait a minute to get this board to flip over. I mean, it could be a fault on the microcontroller telling this circuit, like one of the outputs on the microcontroller telling this circuit to activate all the time. Maybe something we can check as well. Right, so this is the output here. So the triax pins are here, here and here. So it looks like this is power, and then it switches it from here to here. So it's actually activated, the gate is activated by these connections here, which looks like goes through a resistor and then up to these transistors here. So where does this one go? That one. So it goes to that transistor there. So that does one motor and that does the other motor function. So let's check those 2 transistors and see if we get similar readings on them. Now I don't know which pin out's which, but well, that was a good guess. I mean, those aren't blown, and they're measuring pretty much the same. Tell you what, I'm going to put this over that side. And what I'm going to do, I'm just going to try going between the ground here, because there's a pin here marked ground, and we'll just see. Oh, actually, that's got the rest of the pin outs marked there, I didn't see them. I'll just zoom down a second. Alright, so I've got ground, VCC, VDD, and TMP underscore, whatever that means. So I think if we go on ground, I'll just go on to volts DC, we'll go on to ground and we'll go on motor R and motor L, and we'll see if we get any voltages on those. Right, I'm just going to plug it in a second, and I'll just zoom out a fraction so you can see the meter. So I'm going to go on ground. So motor L is the 5th one up, so 1, 2, 3, 4, 5. I've got nothing on there. Nothing on there. I'll just check we've got any voltage going into this board. 4.4. Might be a little bit low, that. I wonder if it would be a power supply problem. What's a VDD say? 4.4. I'm just wondering if it could be a capacitor problem or something. I don't know how it regulates the supply, unless this is here, this is that's a voltage regulator. Right, I'll just unplug this in a second. Actually, if I unplug this, just a thought, if I unplug this, this shouldn't be getting any control signals now. And if I plug this in and then power it up, we'll see if the motor kicks into action. Yes, it does. Right, so the fault's definitely on this board now. We definitely know that 100%. Right, I'm going to disconnect this board now then. I've got it unplugged. Got the board out, so what I think I'll do, I'll move this off the bench and we'll have a look at this board. Right, let's zoom down a bit then. So I think this might be the voltage regulator here. Let's see if I can zoom down a bit and see if I can see a number on it. Try getting a bit closer maybe. There we go. Right, so that's a 7805, so that's a 5 volt regulator. And it looked like we were only getting 4 volts. So the output's the right hand pin here. So let's see if that goes to the VCC or whatever over there. Yes, actually it does this, hold on. Actually no. That goes through a couple of diodes, that's why. Yeah, so the power input comes in here. That's ground, and that's the output, which then comes down here. Goes to this point here, but then it goes through a couple of diodes and ends up over here. It seems to go through a few resistors here. I'm getting a bit lost off with it now. So this is the main smoothing capacitor. So let's measure that. Right, so we're getting 962 there, and it's supposed to be 1000, so that's not too far off. And we've got 3 capacitors here that's supposed to be 470, so let's see what those measure. That's about 813, so I guess 2 of them must be in parallel. I'm not sure about that one. I mean, it's supposed to be 470, we're getting 611. But the problem is, sometimes you can't measure stuff in circuit properly. You've actually got to take it out to measure stuff properly. I just don't know why we're only getting 4.4 volts there. That seems a bit odd. And there's no obvious component damage that I can see. I mean, what we could do is swap the triac from here to here, see if that makes any difference, and then swap the transistor from here to here, because they're both the same, see if that makes any difference, and narrow it down that way. I'll remove the transistors and measure them just to double check. I think I'll do that. I think I'll remove the triacs first, and we'll just see if there's any problems there. Right, I'll go and get the iron. Right, I'm just going to put a little bit of flux on these. Let's put some fresh solder. I'm going to change the tip on siding as well. Just get a bit of solder wick. And it's a bit warm. Right, so we're getting about 86. I shouldn't get anything between those pins. So I think that measures okay. Let's take this one out and we'll just compare it. Just cut this bit of wick off here. I'll just zoom down a little bit so you can see. You can see what I'm doing a bit better. So we'll hold on that pin slightly. There we go. So 87. 82. So I couldn't see the meter there. So on this one we get about 82. And on this one we get about 85. Well, I would have thought both of those are okay then. They're both very similar readings and no two components are usually identical. Right, I think we'll just start checking just different things because I haven't found anything obvious up to now. Let's just try these diodes just in case. Yeah, they're all okay. $10K. I'll just check all the 10Ks first. Four point seven. 4.7, 4.7, 4.7. Well, I'm kind of scratching my head with this one. Everything looks okay. I've got some diodes down here. Let's just double check those. I don't think those are anything to do with it. The only thing that I found so far is it seems like the supply voltage is a little bit down. But all those are okay. These just look like back EMF diodes or whatever for the relays here, just to stop, just when the relays get switched off, it's just to stop a reverse surge going back down the lines to the microcontroller. Right, so where does more L and R come from? It's 1, 2, 3, 4, 5 and 6 pins up on here. So this one. Goes down to here. Yeah, it's pretty much to that transistor. I mean, there was a capacitor across it. I couldn't have. I'm wondering if it is something to do with the supply voltage, you know. That's what these two transistors are for. I don't know if they're the same as the rest of them. I'm just going to have a look through my magnifying glass. Well, that's a 9014, which is the same as all of these, and this one's a 9015. Well, none of them are measuring short or anything. Yeah, I'm really scratching my head with this one at the moment. So, I was just having a quick trace through this circuit, and I just thought I'd try and measure these again. Now, I've got it on ohms now, and what I've noticed is, if I measure between this pin and that one, on this triac, we don't seem to get any reading. If we do it on this one though, I mean, it's in mega ohms, and then it goes to open circuit. Well, let's try that again. It's a bit weird. There you go. If I measure from there to there, 82. From there to there, 81.5. If I swap the leads around and measure from there to there, fine. There to there, fine. If I put the leads this way, there to there, fine. On this one, there to there, we get a slight reading, and then it seems to disappear. So I wonder if it is this triac. Let's see if I go another triac. We'll just pop it in, and then we'll reassemble it just to see what it does. I think that's going to be the best thing.
A few moments later.
Right, so I've had a rake around and I found a triac. However, this one's a 600B and these are 600Cs. And when I've looked at the data sheet, the only difference seems to be that the 600Cs have got a more sensitive gate than the Bs. I think these are 50 milliamp and these are 25 milliamp to trigger the gate, so but I would have thought it should be okay still. So let's just check. If I go between that pin and that pin, I have about 81 ohms. This one and this one, we get about 64. If we go between the two pins here, we don't get any reading. And if I swap the leads round, we don't get any reading. So I'll just try this one again, which is the one that I suspect could be faulty. And there we seem to get meg ohms, but then it disappears. So I'm going to put that one in the L motor, and we'll put this one back in the R motor. Right, I'll just solder those up. I'm just going to trim these excess legs. I'm just going to give it a quick clean up with some IPA and a toothbrush. Right, let's put that to one side, and then we'll go and get the rest of the bread maker and we'll see what it does. I know the red one went there. I'll probably have to have a look back at my little photo just to see where these other wires went. Right, so black went there. Blue went there, white went here and yellow went there. Right, let's switch it on. We'll see if it does the same as what it was doing before. Just plug it in. I'll just zoom out a fraction. Well, it hasn't exploded and the motor's not going. I'm still curious to find out what the voltage is on that regulator is though. Let's see if I can get this to stand up or something. I'll just zoom out a fraction and get the meter in shot. Get my volts decent. Right, so got 15 volts going in and 5 volts coming out. Right, so that does seem right. So I think the power supply might have been a little bit of a red herring. Right, I'm just going to put this back together. I was kind of expecting a triac, but I thought it would have been sort of dead short. So my initial gut feeling was kind of right. Let's put this cover on and then we'll switch it on and we'll just see that the motor actually still comes on when we start it doing something. Now I've got no idea how you use this, or this model anyway. Let's pop that there for the moment. Right, let's switch it on. Pizza dough, that's what I wanted. Right, hit start. I bet you that's why it's failed. Because it uses it to pulse the motor rather than just keep going. I think it's a 2-speed motor. I think one must be sort of slow and one could be fast. It could be one's left and one's right, I don't know. That seems to be working. Right, does this stop it? Yes. Excellent. Right, so what I'll do, I'll put it back together and then I think we'll give it a real world test and we'll try making some pizzas with it. I'll just unplug it for now. So before we return it back to the customer, I'll get one of the other guys to test it just to make sure that everything's safe and whatever. That's one of the things that we'll do at the repair cafe. But I'll bring up the website for the repair cafe in case anybody's interested. Now this isn't just for our repair cafe per se, this is for the whole repair cafe organisation. And it's obviously where people volunteer to help other people repair items, pretty much. We get a variety of different things in, but obviously I mainly work on electrical stuff. So, right, we'll pop this back in, and then we'll put the lid on, and then we shall go give it a test. Right, I've got the bread maker set up in the kitchen, and I'm just going to use the recipe that came with my bread maker for making pizza dough. That's the recipe there. So put the water in first, so 1.5 cups of water, and then we need 2.5 tablespoons of olive oil, 4 cups of strong white bread flour, 2.5 tablespoons of sugar, 1.5 teaspoons of salt, and then it says 2.25 teaspoons of dried yeast, but I'm just going to use one of these packets and chuck that in. So right then, let's select pizza dough. Pizza dough, that's it, and we'll hit start. And it says it's going to take 55 minutes. So it's been wearing away for a few minutes now, and we're getting a nice ball of dough there. just finished kneading and now it's making the dough rise, and it says it's got another 30 minutes left. So while it's doing that, and it's gone a bit quieter now, I'm going to make some pizza sauce. So how I make this is just some peeled plum tomatoes. I'll just chuck that in this jug. Some tomato puree. Just squeeze all that into here. I've got 3 cloves of garlic that I'm just going to squish into this. Just get those in there. And I'm going to put a teaspoon of some mild chili powder just to give it a little kick. Something like that. And then I'm just going to whiz it all together with this hand blender. And then I'm going to chuck a bit oregano in, or a bit oregano for our American viewers. Just chuck a bit of that in there. And then I'm just going to give it a mix. And there we go, pizza sauce. If you find it's a little bit thick, you can also add a little bit of water, or if you want to add a bit of sugar, feel free to do so. It's open source. Right, I think that means it's finished. It's just busy started beeping there, so let's have a look. And there we go, we've got some pizza dough there. Right, let's make some pizzas. The first thing I'm going to do is sprinkle a bit of flour on my bench here, so it doesn't stick. And then I've just grabbed about a tennis ball size of dough, and I'm just going to use a rolling pin just to roll it out. I normally make thin pizzas, so thin base, not deep pan. But you can make deep pan with this dough as well. So a bit more flour to that. So something a bit like that. Right, I've got my pizza paddle. Just get it on there. We'll get a bit of this pizza sauce on it. Like I said, if you find it's a bit thick, just add a little bit of water to it. Just be careful not to go over the edge, because otherwise you'll have trouble getting it off the pizza paddle if you've got one. Now before we moved here, I've never made pizzas before in my life, so we used to just get them from takeaway, but because we live that far away from takeaways, it's not really convenient or practical even. There we go, something a bit like that. Right, just check that's not sticking. Right, let's get a little bit of cheese on there now. Just using some grated mozzarella. And this one's going to be pepperoni and sweet corn, because that's what the kids like. So usually make the first one for the kids and then we'll make some other ones. Right, we'll get a bit of pepperoni on there. And a little bit of sweet corn. Right, so another little tip. Give it a shake first. Like that, to make sure it's not stuck. Because I had it before when I first started to make them. I tried to shove it onto the pizza stone and it just went so I always do that now just to make sure it's not stuck. Right, we'll get this in the oven. Right, there we go. In the oven, so we'll just let that cook. Well, I think that should be it, just about done. Let's have a look. Oh, look at that. Right, let's get that on a plate. So, it looks like the bread maker works fine. And we've got pizza to go with it as well. Right, so give these a try. Everybody that's tried them said that they're really good, so I think I'm going to have a taste of this. Yes. Right then, if you enjoyed this pizza, please give it the thumbs up. If I made you hungry, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, Have a great day. Thanks for watching.